Good day, class. So your next topic will be elasticity. Okay? So simply, elasticity in physics, elasticity is the ability of a body to resist a distorting influence and to return to its original size and shape when that influence or force is removed. Okay? So, para mas simple, yung elasticity is a property of an object. Okay? Na if it is subjected to force, it will deform, and kapag wala na yung force na yon, ay babalik siya dun sa dati niyang itsura. Okay? So, dito sa topic natin na elasticity, so a body is an example of an object that does not deform under the actions of external forces. So merong mga particle or object or mga bagay na hindi sila nagde-deform kapag if they are subjected to forces. Okay? So the extent to how an object is perceived as rigid depends on the physical materials to which the object is made. So as discussed in dynamics, forces causes motion, but aside from motion, forces could also cause changes in an object, okay, such as its length and volume. Okay, so this change is known as the deformation. Okay, so meron tayong mga terms na mamimit as we go along the way dito sa module natin. Okay, so dun sa past modules natin, we have discussed yung dynamics. Okay, na yung forces, it causes motion sa mga object. Tama? If you pull something, 'di ba? Nag-exert ka ng force, and yung thing na yon or yung bagay na yon, if you pull it or you push it, gagalaw siya, 'di ba? Because of the force na ina-exert mo. Okay? And there are things or mga bagay na if subjected to forces, they will not only cause motion but also, sabi niya dito, change in its length, okay, and volume. So example, kapag isang yung bagay is piniga mo, no, yung magche-change yung volume niya, di ba? Or yung rubber, di ba, kapag hinila mo, magche-change yung length niya, hahaba, ganun, di ba? So magkakaroon siya ng deformation. Okay? So deformation is experienced by object through the application of external force such as twisting. So twisting, that is torque, yung last na topic natin. Okay? Shear, tension, and compression. Okay? So we will define that later. When an object experiences deformation, the forces on the object are described by the stress and strain. Okay? So i-define natin yung mga terms para mas maintindihan ninyo. So we have the stress. Okay? So stress is the measure of the forces that causes the deformation. It is applied force perpendicular on the area. Okay? So simply, stress is equal to force over area. Okay? So it is a measure of force that causes the deformation. So stress, para mas maintindihan nyo, it's like a pressure. Okay? So the quantity of force divided by the area. So yun lang yung i-memorize ninyo. Stress is equal to F over A. Okay? So first we have what we call the tensile stress. So it is when a force pulls an object causing it to elongate, as in figure A. Okay? So dito sa figure A, so kung nakikita ninyo, yan, palakin ko lang ng konti. So ito yung figure A natin. So sabi natin, tensile stress is when a force pulls an object causing it to elongate. Okay? So kapag example na lang yan, so i-drawing ko na lang ulit. So if we have an object, so sabihin na lang natin na it's a cylindrical object, okay? No? If it's subjected to force, tendency na pwedeng mangyari dyan, tensile, ibig sabihin hihilain. So yun lang yung parang pinakasimple para sa maintindihan nyo. So tensile, hilain, tension. Okay? So from the word tension. Yan. So if it is subjected to a tension force, So, pwedeng mangyari dyan is mag-elongate siya, no? Like yung rubber or spring, no? Mag-elongate siya with a certain length of uh, delta L. Okay? So, magkakaroon siya ng kung ito yung dati niyang length, okay? If this is the original length, because because of the force, pwede siyang humaba. Okay? So, that is pwede siyang humaba at a certain delta L. Okay? Ayan, kuha ninyo. So, kung ito yung original na length niya, because of the force na in-apply natin, tendency hahaba siya. Okay? So, meron siyang change in length. Okay? From the original length, meron siyang bagong length. Okay? Kuha ninyo. So, like yung nandito sa figure na ito. Okay? So, parang inulit ko lang na din drawing yung yung example natin dito sa figure A. Okay? Kuha ninyo. So, dun sa figure A natin, meron tayong original length. Ito yon. Ayan. And because of the force, of the tensile force, humaba siya. Okay? So, nandito na yung ating naidagdag na length. Okay? Kuha ninyo. So, ito yung delta L natin or yung change in length natin. Okay? So, that is tensile stress. Okay? So, for yung stress natin, that is denoted by sigma. Okay? This is what you call sigma in Greek Greek lettering. Okay? So next we have the what we call compressive stress. Okay? So compressive stress naman is when a force causes compression and the object shrinks. Okay? As in figure B. Ano niyo? So compressive, compression. 'Di ba? Pwedeng lumiit yung isang bagay kapag kino-compress mo. Kuha. So that is yun yung tinatawag na compressive stress as in figure B. Nakikita nyo naman tong figure B, we have in object, so cylindrical object. Okay? So kung ito yung dati niyang itsura, so surat ko lang ulit, no? So compressive stress, from the word compressive, compression. Okay? So towards the object yung ating direction ng force. Okay? So dahil towards, pwede siyang mag-shrink. So, example, itong figure B natin, di ba? Ito yung original na length niya. Okay? Kuha nyo. And because of the force, pwede siyang lumiit. Okay? Na magiging hanggang dito na lang siya. Ayan. No? So, magkakaroon ulit tayo ng change in length. Okay? So, ayun. The tensile and compressive. Basta tensile, tension, hihilain. Compressive, i-compress. Then we have the bulk volume stress that is denoted by P. So the stress experienced when an object is compressed from all sides, usually experienced by object in fluids. Okay? So we have what we call bulk stress. So example na lang dito, itong figure C natin. Nai-stress siya on all sides. Kaya natawag siyang bulk or volume stress. Kung titingnan niyo yung figure A and B natin, parang rod lang siya, no? If you can, for example, yung bakal natin, no? So, parang rod lang siya. So, makaka-experience siya ng tension doon lang sa isang side. Okay? On both, magkabilaang side lang, di ba? As you can see in figure A and figure B. Now, for the volume or bulk stress, all sides. Okay? So, if we have an object na square, so, lahat ng sides niya nakaka-experience ng force. So, it experience stress. Okay? So, yan. And we have what we call the shear stress. No? So, the stress experience when deformation is caused by tangential force to the surface. Okay? So, ang pinagkaiba ng class dito sa tensile and compressive, perpendicular yung force natin. Okay? So, para mas makuha ninyo yung tensile and compressive stress that is perpendicular. So for example, ito yung area natin, ito yung area subjected dun sa force. Okay? So we have force. Ngayon, yung contact area natin is this one. Okay? Yun. So stress will be equal to force over area. And yung area na gagamitin natin will be yung perpendicular dun sa force. Okay? As you can see, di ba? Horizontal yung ating area, vertical naman yung force, kaya perpendicular sila. Okay? So that is the same with tensile and compressive, kahit pa either pahila yung force natin. Okay? As long as perpendicular sila. So that is either tensile or compressive. Ngayon, kapag shear stress naman, class, yung force natin is parallel dun sa area. Okay? So if we have ito yung contact area natin, yung force natin will be parallel. Okay? So therefore, same lang din yan, stress, shear stress denoted by T or ayan. That will be equal to force over area din. Okay? So same lang, that is parallel pag shear stress. Okay? Parallel yung force dun sa contact area. Okay? So para mas maintindihan nyo, shear stress is yung sliding force. Okay? Pag nag-i-slide, so shear, kasi yung force niya, sliding, yung force is parallel dun sa contact area natin. Okay? So next, we have the units of stress. Okay, yung unit ng stress natin, naka-pressure yan, no? So that is equal to, sabi natin, force over area. Ang unit ng force is Newton. Tama? Or pounds. Depende. Ang area naman natin is measurement yan, di ba? Square meter, square foot, square inch, square centimeter. Okay? Kaya ang unit ng force, di ba, is Newton. Tapos area naman is meter squared. Tama? Okay. So, yung Newton over meter squared, that is what we call Pascal. Okay? So, si Pascal yon, no? Yung Newton over meter squared. Okay? So, kapag sinabi natin, so, Newton over meter squared, so that is Pascal. Kapag kilopascal naman, di ba, di ba, sa unit natin, kapag kilo, times mo siya ng 1,000. I-divide mo pala ng 1,000. Okay? So, kapag 1 kilonewton, sabi natin, 1 kilonewton over meter squared. So, this is also equal to 1 kilopascal. Okay? Or 1 kPa. Kaya, naka-pressure siya. No? Yung PA or Pascal, that is pressure. Okay. So, sa English, ganun din, pounds per square inch, or that is what we call PSI. Okay? So, andyan yung conversion. 1 PSI is equal to 6,895 Pascal. And we have the atmospheric pressure, often used for bulk stresses. Okay? So, 1 atmospheric pressure is equal to 14.7 PSI. Okay? Or 1.013 times 10 raised to 5 Pascal. Okay? And next, we have the word strain. No? So, kanina, stress yung dinefine natin. Ngayon naman, strain. Okay? So, strain is the quantity that describes the deformation. Okay? So, it is a dimensionless value. Okay? It is a fractional change in either length for tensile compression or volume or shape or shear. Okay? So, we have a type of strain. First is linear strain. Okay? So, yung symbol natin dyan is epsilon. Yung sa mga Greek letters pa rin natin. So, yung formula natin, sabi kasi natin sa strain is a fractional change in either length. Actually, ito yung ratio, yung strain natin is the ratio of the change in length before over dun sa total length. Okay? So, for example, ito yung ating object, no? So, example, this is a rod, okay? And subjected siya dun sa force natin. So, So, we have a rod with a length of LO. Kuha. And it is subjected to force. Ngayon, kapag nag-elongate siya, di ba, mag-elongate siya. So, magkakaroon tayo ng change in length. So, from original na length na yan, so, pwede siyang humaba. Okay? So, i-exage ko na lang para makuha nyo. Yan. So, pwede siyang humaba, no? So, from the original length natin, ito yung LO natin, di magkakaroon tayo ng change in length ngayon. Kasi humaba na siya. So, nadagdagan siya ng length. So, that will be delta L. So, therefore, sabi natin, strain is the ratio of the deformation over yung total yung original length niya. Okay? So, strain, linear strain is equal to yung delta L over yung original na length niya. Kuha niyo. So, kaya naging dimensionless siya kasi kung meter ito and meter din yung length, yung unit nito, cancel yung meter natin. So, wala siyang unit. Okay. So, ganun. So, for shear, that is denoted by gamma. Okay. So, delta x over y, and for volume, theta naman, delta volume over yung total volume niya. Okay. So, ganun. Delta or change in length over total or over yung original na length niya. Okay? So, simply yun yung strain. Now, we have the elasticity. So, dinefine ko to kanina. So, ito yung parang pinakaano ng concept ng ating module. Okay? So, elasticity is the ability of a deformed material body to return to its original shape. Okay? So, size when the forces causing the deformation are removed. So, yun, sinabi ko kanina, elasticity is yung ability ng isang bagay na bumalik sa dati. No? If you have a material na subjected sa force, kapag naalis yun, babalik siya sa dati niyang shape. Okay. So, paulit-ulit, naintindihan nyo na yun. Alam ko. So, Hooke's law, discovered by English scientist Robert Hooke. Okay? Galing siya sa name. No, kapag may nadidiscover kasing bagong bagay, pinapangalan dun sa nakadiscover. Okay? So, discovered by English scientist Robert Hooke in 1660. Okay? So, a principle of physics states that for a relatively small deformation of an object, the displacement or deformation is directly proportional to the deforming force or load. Okay? So, yun yung Hooke's law natin. So, Hooke's law defines that yung force daw natin sa isang object, okay, is directly proportional. So, remember nyo yung mathematics of engineering nyo. Directly proportional siya doon sa deforming force or doon sa change in length natin. Okay? Deforming force or load. Okay? So, therefore, para makuha natin yung equation natin, itong directly proportional na to, para maging equal siya, kailangan natin ng constant. Okay? So, that will be F is equal to, so meron tayong constant multiplied by delta X or yung change niya. Okay? So, the deformation of the object. Okay? So, yung K natin yan, that is what we call the constant or yun yung spring constant natin in the case of spring. Okay? So, may negative tayo. So, that is negative. Negative sign indicates the object is returned to its original state. Okay? So, for ito, example natin, yung sa case ng spring. So, we have a spring dito. Okay? Itong part na yan. Unstretched spring. Okay? So, from Hooke's law, F force is equal to negative kx. So, para mahila natin yung spring at an x, okay, at a distance x, so we need a force. Okay? So, sabi niya dito, it takes twice as much force to stretch a spring twice as far. So, meron tayong force, di ba? Okay? And a distance x. So, na-stretch natin as the distance x. So, kapag meron tayong x, meron tayong f. Ngayon, kapag naging 2x ito, ibig sabihin, ito will be 2f then. Okay? So, it takes twice as much force to stretch the spring twice as far. Kaya proportional siya, directly proportional. Kuha ninyo na kapag kapag lumalaki yung change, yung deformation natin, lumalaki din yung force. Or the other way around, kapag mas malaki yung force, lalaki din yung change in length natin. Nakuha ninyo? Siyempre, kung mas mataas yung force, mas mahihila yung spring. Kuha ninyo? Kaya directly proportional siya. Okay? So, yun. So, next, we have what we call the elastic moduli, or the coefficient that relates a particular type of stress. Okay? Resulting to the resulting stress. Okay? So, yung modulus, or that is denoted by E or gamma. Okay? So, that is for stress and strain, normal force to area, that is stress, linear force, linear deformation, epsilon, dun sa strain naman yon. Okay? So, elastic modulus, we have Young modulus, shear modulus, and bulk modulus. Okay? So, sa Young modulus, yun yung para doon sa normal stress or doon sa stress natin na tensile or compressive. Okay? So, Young's modulus ang tawag natin. For shear stress naman, shear modulus naman. Okay? So, yun. Next, we have the Young's modulus of elasticity. It is a quantity that describes a material in response to stress applied to area. So, it can be defined simply as the stiffness of a solid material. Okay? So, Young's modulus is the property din ng quantity that describes yung stiffness ng ating material. Okay? So, lahat ng bagay, either wood, concrete, steel, so may mga Young's modulus sila. Okay? Or any plastic, kahoy, meron silang kanya-kanyang stiffness, okay? Or Young's modulus. Okay. So, Young's modulus states that the stress applied to the body is directly, so meron na naman tayo, no? Directly proportional to the strain induced on the body. Okay? So, yung Young's modulus natin states that that stress is directly proportional to the strain. So, ano yung letter natin sa strain? That is denoted by epsilon, di ba? Okay? Strain. So, ibig sabihin, yan yung ating Young's modulus. So, para maging equal sign na naman tong sign natin ng directly proportional, kailangan natin mag-introduce ng constant. So, that is, stress will be equal to K, that is constant, multiplied by the strain. Okay? And sabi natin, yung K na to, yan yung Young's modulus natin. Okay? Or that is the gamma or Y. Okay? Yan. So, that will be, therefore, stress is equal to the Young's modulus ng material multiplied by strain. Okay? So, dun natin nakuha yon. Kita ninyo? Okay. Pero, sabi natin, ulit, class, stress is equal to, so, dito tayo sa gilid, So, explain ko lang yung derivation ng ating formula. Pero sabi natin yung stress is equal to force over area. Okay? And yung strain naman natin, that is equal to change in length divided by yung original na length niya. Kuha ninyo? So, therefore, kapag sinubstitute natin and sabi natin stress is equal to Young's modulus times E. Okay? Therefore, yung Young's modulus natin is equal to stress over strain. Kuha ninyo. Kapag sinubstitute natin yung value ng stress dito, so that will be, magkakaroon tayo ng force over area. So, ano yung value ng ating strain? That is delta L over yung original na length natin. Kuha ninyo. So, therefore, ito yung formula natin for Young's modulus. Okay? Nakuha ninyo? So, yun. So, let's continue, class. So, note, Hooke's law may be also be stated in the same relation as Young's modulus, okay? Where the strain in a solid body is directly proportional to the applied stress within the elastic limit of the solid body. Okay? So, we have what we call the stress-strain diagram. Ano niyo? So, nakikita ninyo. So, ito yung tinatawag natin stress-strain diagram. So, we have the, for the x-axis, okay? The x-axis, we have the strain, and for the y-axis, we have the stress. Okay? So, ito yung elastic diagram natin. So, in material, sabi natin, stress and strain are proportional. Kaya, from 0 na stress, 0 din yung strain niya. Okay? So, magkakaroon tayo ng straight line. Kuha ninyo. No? And at some point, okay, so elastic region, elastic pa yung bagay natin, no? Example, if we have a rod, a steel, if subjected to force, so directly proportional yung stress tsaka strain niya, no? Kapag tumataas yung force, tumataas yung stress, tumataas din yung strain niya. So directly proportional, no? Kaya straight line tayo. Ngayon, pagdating dun sa point A, okay? Pagdating dun sa point A, may merong time na magiging plastic na yung object natin. Okay? So, from elastic region, di ba yung sa elasticity, sabi natin, yung bagay kapag nahila, kapag tinanggal mo yung force, babalik sa dati. Pero, meron yung time at a point na kapag nasobrahan mo yung hila mo, at pag binitawan mo siya, hindi na siya babalik sa dati. Okay? So, magiging plastic siya. Okay? So, ito yung region natin from A to B. Yun yung medyo elastic pa rin siya, no? Yung from A to B natin. Okay? Pero, malapit ka na doon sa point na magiging elastic na siya. Okay? Which is, kapag titingnan ninyo, yung strain natin, tumataas pa rin. Pero yung stress nyo, hindi na. Okay? So, parang the same force, pero yung strain mo, dire-diretso. Okay? Okay nyo? So, dito is plastic region na. No? Na yung ano mo, yung bakal mo, or yung material mo, kung ano man yan, hindi na siya babalik sa dati niyang size. Okay? Or sa dati niyang length. No? Until such a time at point D, so, naging curve na siya, no? Na pwede pang, kaya niya pa yung ma-induce yung stress, pwede pang tumaas yung stress niya, pero, humahaba na yung strain niya. Kuha ninyo? Okay? So, you will encounter this in your higher subjects, dun sa mechanics or strength of mechanics of deformable bodies, or sa higher subject ninyo, okay? So, yun. So, class, we have a sample problems. Magsagot tayo ng sample problems. Okay. So, number 1, we have a sige. Mahirap ibaba. Okay, sige, sagutin natin to. How much force is needed to pull a spring with a spring constant of 20 Newton over meter for a distance of 25 centimeter. Okay? So, sabi natin, ano yung mga given natin dito? Okay? So, ilang force? So, dun muna tayo sa given. So, we have a given na spring constant. So, yan is K, di ba? So, K is equal to 20 Newton over meter. Okay? And, distance natin, or yung delta X natin, that is equal to 25 centimeter. So, yung tanong sa atin, how much force is needed to pull a spring? Okay? So, sabi natin, force is equal to delta K multiplied by X, or yung change in length, delta X. So, meron tayong spring. Nakita nyo yung given dito sa figure. So, ito yung original na shape ng spring natin. So, ilang force daw yung kailangan natin para mahila natin yung spring at a distance of 25 cm. Ito. Kuha nyo? So, that will be equal to, force is equal to K delta X. So, substitute nyo lang. So, force will be, yung K natin, 20 Newton over meter. Then, multiplied by change in deformation, that is delta X, 25 cm. I-divide nyo na lang ng 100 para maging meter. So, that will be 0.25 meter yan, class, ha? Okay. So, that will be, cancel yung meter natin. So, force na kailangan natin will be 5 Newton. So, yun. Simply as that. So, next problem tayo. So, a nylon string has a diameter of 3 mm and is pulled by a 150 Newton force. So, determine the stress. Okay. So, given natin, class, so we have a nylon string. Diameter natin is 3 mm. Okay. And pulled by a force of 150 Newton. Okay. So, 150 Newton. Okay. So, drawing ko lang. So, example, meron tayong nylon string. Okay. Ayan. So, yung diameter na ito is 3 mm. And pulled by a force, no? Ayan. Okay. Determine the stress. Okay. So, for our solution, so sabi natin, stress is equal to force over area. Okay? And sinabi ko kanina, yung area na to is perpendicular dun sa force. Yung area na to is yung contact area ng force. Kung papalakihin ko ito, class, ganyan yung itsura niya, di ba? Kuha ninyo. And ito yung contact area natin. Ayan. Therefore, ano yung area natin? So, compute the area given diameter. Okay? So, that will be for area. Ano yung formula ng area? That is pi over 4 d squared. Tama? So, compute nyo. That will be pi over 4 times 3 mm. Ngayon, naka-mm siya, no? So, convert natin siya into square meter. Okay? So, kapag ko-convert mo yan, so i-times mo ng ilang mm ang meron sa 1 meter, that is 1,000 mm. Tama? So, that will be 1 meter over 1,000 mm. So, cancel yung meter mm natin. Mm yung matitira. Pero, naka-squared ito, so dapat squared din yan. Kuha ninyo. So, that will be, area will be equal now to 0. Okay, 7.068 times 10 raised to negative 6 square meter. Kuha ninyo. So, you input that in your calculator. Okay? So, yan yung area natin. And, sabi natin, stress is equal to force over area. So, therefore, stress is equal to, ano yung force natin? 150 Newton divided by area, 7.068 times 10 raised to negative 6 square meter. Okay? So, that will give us 21.22 megapascal. Okay? So, bakit megapascal? So, kapag i-compute nyo, di ba, sabi natin, Newton over meter squared, that is Pascal. So, try nyo, 150 divided by 7.068 times 10 raised to negative 6. So, that will give us 200. 21,222 for 10.87. Okay? So 21,222,410.87 Pascal. Okay? So uh, kapag gawin nating megapascal, so i-divide natin siya ng 1 million, tama? Okay. Kapag kilo, 'di ba, yun di-divide mo siya ng 1,000, magiging kilopascal. Okay? So kapag dinivide mo siya ng 1 million, so that will be megapascal. Mega. Okay? Nakuha ninyo? So that will be equal to, divide yan ng 1 million, magiging MPa or megapascal. So that will give us 21.2224 megapascal. Kuha. Ayun. So same lang din, pwedeng ito rin, no? Pero ito para at least medyo mas maikli yung answer ninyo. Okay? Hindi siya million. Kuha ninyo. So next problem. Say string of 4 mm in diameter has original length of 2 meters. So the string is pulled by a 200 Newton force. So if the final length of the spring is 2.02 meters, determine A, the stress, B, strain, and C, the Young's modulus. Okay? So class, ano yung given natin? So we have a string. Ano yung string natin? We have a diameter of 4 mm. Okay? And it has a original length. So ano na lang natin yan na LO, original length na 2 meters. Okay? So, and we have it is subjected to a force. Hinila siya by a 200 Newton na force. Okay? So, if yung final length niya is 2.02 meters, so, final length, sabihin na lang natin na L1 or L final. Okay? Final length, sabi niya eh. So, LF, so that is 2.02 meters. Okay? So, kapag dinrawing ko siya, parang ganito yung itsura niya. We have a string, no? Sabihin na lang natin ganyan. So, kapag nahila siya, subjected siya dun sa force. Okay? Ngayon, may original length siya. Tama? Na LO. Kuha. Okay? So, nung hinila siya, nagkaroon siya ng final na length. Okay? So, final length natin, ayan, no? Ito yung final length natin. Ngayon, kukunin natin yung delta or yung change in length niya. Okay? Yung delta L. Kuhanin nyo. Drawing ko lang ulit para makuha. Palakihin ko na lang. Okay? So, ito yung original. Then, nung nahila siya, nagkaroon tayo ng delta change. Okay? So, ito, LO. Ito, L final. Therefore, ito is delta L. Kuhanin nyo. Because of the force na na-apply. Okay? So, first, determine the stress. Okay? Solution muna tayo. So, kunin muna natin yung change in length niya or delta L. So, that is equal to L final length minus initial length, original length, LO. Okay? So, substitute nyo na lang. So, that is equal to 2.02 meters minus 2 meters. So, that is equal to ilan? 0.02 meters. Okay? Yan. So, solution natin, letter A, stress is equal to force over area. Okay? So, diretso nyo na. Force, ano yung force natin? 200 Newton. Divided by, ano yung area natin? So, diameter natin is 4 mm. Oops. So, 4 mm, diameter natin. So, that will be area is equal to pi d squared. Pi over 4 d squared. Okay? So, that will be, so, compute nyo na lang yung area. So, pi over 4 So, 4 mm yan. So, that is 0.004. Tama? Para maging meters siya. So, that will be meter squared. So, 200 divided by 200 Newton divided by yung area. So, stress now will be equal to 15.96, okay, times 10 raised to 6. Sulat ko para mas clear. So, yung stress natin will be now 15.96 times 10 raised to 6 Pascal. Okay? So, ito yung final answer natin, or equal din siya sa stress is equal to 15.96 megapascal. Okay? Basta pag megapascal, raised to 6 yun ng pascal. Okay? So, any of that. Yan. So, next, letter B, ilan yung strain? Okay? So, how much is the strain? So, sabi natin, strain. So, dito na lang ako, class, So, strain. Oops. So, strain is equal to change in the length over yung original na length natin. Kuha ninyo. So, therefore, that is equal to, ano yung change in length natin? That is 0.02 meters over original length natin, 2 meters. Okay? Therefore, our strain is equal to 0.01. Okay? So, sabi natin, dimensionless. So, yan na mismo yung answer natin. So, that is for letter B. Okay? Kuha ninyo. So, ayan. Substitute lang sa formula. Okay? Ngayon, letter C, what is the Young's modulus? Okay? So, for the Young's modulus naman, sabi natin, for Young's modulus, class, that is equal to stress over strain. Okay? Tama? Yan. So, Young's modulus is equal to stress over strain. So, stress natin is 15.96. Okay? So, 15.96 megapascal. Okay, kuha. Divided by 0.01. Okay? Therefore, our Young's modulus will be 15.96 divided by 0.01. 1596. Okay, so that will be 1596 megapascal. Okay? Or this is also called, so i-divide mo ulit ng 1000 yan, magiging GPA ka na. Okay? Or gigapascal. So 1. Pwede mong i-round off. Okay? So that will be 1.6 gigapascal. Okay? So, any of that. Ayan. So, that is our answer for number 3. Okay, last problem tayo. So, that will be ayan, okay? So, number 4. So, we have number 4. A concrete has a height of, so this is 5 meters, class, Hindi na, height of 5 meters. So, i-correct ko lang to, class. This is, ayan, this is 5 meters and has a unit area of 3 square meter. Supports a mass of 30,000 kilogram. Okay? So, determine A, the stress, B, strain, C, change in height. So, Young's modulus natin para sa concrete is 20 gigapascal. Okay? So, Ano yung mga given natin, class? So, given. So, we have a Young's modulus, which is 200 gigapascal, or that is equal to, kapag gigapascal naman, di ba, kung kilopascal, kPa, that is times 10 raised to 3 pascal. Kapag megapascal, that is times 10 raised to 6 pascal. Pag gigapascal, GPa, that is times 10 raised to 9 pascal. Kuha ninyo? Yon. So that will be, we have 20 times 10 raised to 9 gigapascal. Kuha. O yan. Hindi na. Pascal na yon. Okay? Or that is equal to Newton meter. No? So, ayan. And then, ano yung iba pang given sa atin? So, supports a mass. So, we have a mass that is equal to 30,000 kilogram. Okay? And concrete height, so this will be our original na height, LO or length, that is 5 meters. Okay? So yung M natin, so i-convert natin to sa parang magiging force yan, di ba? Yung force natin will be weight. Tama? So sabi natin, weight is equal to mass times gravitational acceleration. So weight will be 30,000 kilogram times 9.8. Okay? So 9.81 meters per second squared. Okay? So yung weight natin will be 294,300. So anong unit nito, class? Magiging Newton na. Okay? Ayan. Then we can solve na ano yung hinahanap sa atin. So for solution, so letter A, what is the stress? So stress is equal to force over area. So stress will be, ano yung force natin? Yung weight niya mismo. Okay? It supports a weight. Okay? So meron pa tayong isang given, area. Okay? Area natin is 3 square meter. Okay? So that will be, ano yung force natin? Is yung weight mismo natin. Okay? So that will be 294,300 Newton divided by area, which is 3 meters squared. Okay? So that will be, stress now will be equal to, so 98.1 kilo pascal. Kuha. Ayan. Then for letter B, ano yung letter B natin? Strain. So for strain, that is equal to, so epsilon, strain is equal to the change in length over the, ang tawag na to? Over LO. Okay? And sabi din natin, yung Young's modulus, yung una nating formula. Okay? So yung Young's modulus natin, okay? So, Young's modulus natin is equal to stress over strain. Okay? So, stress over strain. Okay? So, pili na lang tayo ng pwede nating formula na gagamitin. So, dito sa base dun sa isang formula natin, Young's modulus, strain is equal to stress over Young's modulus. Kuha ninyo. So, therefore, so dito tayo sa gilid. Ay, baba ko na lang. Okay? So, that will be, strain will now be, ano yung stress natin? 98.1 kPa over yung ating Young's modulus. So, Young's modulus natin will be 20 times 10 raised to 9 pascal. So, i-times natin siya ng 1,000, magiging megapascal. Okay? So, that will be now 20 times 10 raised to 6 para maging pascal, di ba? Sinulat ko pala yun dito sa kabila. Ito, kita nyo? Yan. So that will be times 10 raised to 6. So magiging kilopascal siya pala. Okay? Kilopascal. Kuha nyo. Ayan. Raised to... Tama ba? Oh, tama. Kilopascal siya kasi yung ating unang yung given natin, di ba, is wait lang ha. So ito is nakapascal siya, di ba? Kita nyo, nakapascal ito. So kapag tinimes natin siya ng 1,000, so mababawasan siya, magiging raised to 6 na lang. Pero magiging kilopascal na siya. Kuha. Kaya naging raised to 6. Yun. Okay, so wag kayong malito yung sinulat ko kanina. No? So, ayan. So, that will be so 98.1 divided by 20. So, strain natin will now be 0.00 ilang 0 yon? 1, 2, 3, 4, 5 na 0. 0.00004905. Okay? So, therefore, yan yung ating magiging strain. Kuha nyo? Ayan. So, dimensionless yung strain natin. So, pareho silang KPA. Magka-cancel lang. Kuha. And ano pa yung isang hinanap sa atin? Change in height. Okay? So, ano yung change in height daw? So, meron tayong original na LO. Original height, that is 5 meters. Given naman na yung strain natin. So, sabi natin, strain is equal to change in length or yung change in height, sabihin na natin, over yung original na height niya or LO. Okay? So, pwede rin na LO or height. Okay? So, given that the strain is 0.00004905, okay? So, change in height is equal to strain multiplied by original na length natin. Kuha. So, that is equal to 0.00004905 multiplied by length natin 5 meters. Okay? So, therefore, change in height now will be equal to 0.024 tama? 0.24 525. So, this will be now mm. Okay? So, kapag naka-meters to, mas marami siyang 0, no? That is 0.123 000 apat. Okay? 24525 24525 24525 meters. Okay? Converting to mm, maliit lang kasi siya. So, this will be our final answer. Okay? So, pwede rin ito, no? So, that will be 0.024525 mm. Okay? So, that's it. That's our the end of our module 6.